Welcome to Rges Algebra 2. This is lesson 27A. And obviously we are not having class for the next 3 weeks at least. And please be in prayer for our government officials, for wisdom for our leaders, for strength, for those who are caregivers, caretakers in any capacity, the protectors and those in society associated with the medical profession, all those. Of course, it's a challenging time, and be in prayer for all those who are already touched with sickness, who are fearful, who are concerned about the future. I wanted to encourage you with this scripture: "Blessed be the Lord, who daily bears us up, to bear up, to carry, to embrace and lift in his own arms. God is our salvation, and his love for us, all of us, is powerful, overflowing, more than we can imagine. He is concerned for all the peoples and all the nations of the earth. And I would just encourage you today to look to him, to cast yourself up on his care, to lean into him, and to trust that he is your salvation. What does that mean? To be our salvation is the one who saves, enables, helps, comes alongside. Obviously I don't know, obvious to everybody, but that does include forgiving us from our sin. It includes giving us free access into his throne of grace, but it also includes every area of our lives that we need his help. We can call upon him. So be encouraged by that. And then what we're going to do for this class, I want you to get out your homework that was prepared for today. I will be writing down the answers to your homework problems, covering a few if I think they might be particularly difficult, and then moving on to the new concepts for today, which will be 8.5. So let's go ahead and do that. Let me write those answers down for you. Okay, so these are the answers to 8.4a. I worked out a few of them for you to try to show you what I thought might be new concepts or getting your mind remembering certain ideas. If there are any other specific problems that after you looked at them again, being given the answers and given the hints on the problems that I did cover, if there are any specific problems or any concept you need me to go over again in more detail, I would like you to text my number and give me this problem, the problem set. So these are 8.4a, then the problem number or just the general concept you're still struggling with. And then I will not respond to you directly, but on the next tape, which will be lesson 27b, I will go over things that you request more carefully in addition to answers and new ideas. Now, I recognize I want you to recognize we're doing this because we do not have the class time together to go and review. So please feel free to do that as much as you need to nail these ideas down. Okay. So I am going to then go on to the answers for 8.4b. Now, when both we're going to simplify this, rewrite what's under the radical sign to 7 squared, and when both our exponent and our index can be divisible here, both by 2, this is reduced to the square root of 7. See how that works? Let me go ahead and do another one. We're working on odd problems. The 4th root of 100, write that down to 10 squared. I could also write it to 2 squared and 5 squared, but it doesn't really help me with right now. Okay, so that would be divide both by 2. We get the square root of 10. I think I'll do several of these. 5, the 6th root of 625. I'll do these off the tape and you can study each one. Okay, I went ahead and showed you the work for all but the last couple, trusting that maybe even at this point you're able to do those in your head. Now let's go ahead and give our answers to 8.4c, 1 through 12 all. We are basing these first problems on the Pythagorean theorem. Recall that when we're talking about C, our hypotenuse on the triangle, on the right triangle, across from the 90-degree angle, C equals the square root of a squared plus b squared. So you want to use that, and plugging in for each one. We'll plug in, for instance, in number 1, where a equals 2 and b equals 2. We would have c equals the square root of 2 squared, which is 4 plus 4, or c equals the square root of 8, and now, of course, you want to simplify. Remember, that's 2 cubed. Taking 2 forward, we get to the square root of 2. So we're adding something you've done before, but now using the simplification step as a merger to the other concepts. So number 2 should be 4 the square root of 5. 3 should be 3 the square root of 5. And 4 should be 10. Let's move on to some new ideas then. On number 5 through 9, we are going to plug in for formulas. And so number 5, we have the formula. I'll write this down and show the work, and then explain anything orally I need to for the sake of time here. Okay, here we have the solution to the first 7. Go ahead and put it on pause. Check your work on these. I am showing the work on each one of these, and then I'll continue with 8 through 12 on the next page. So here we go. These are the answers for the next ones. I'm going to finish 12 on the next page. So put it on pause, follow along, and then let me wrap up that last one. So this concludes the problem number 12, which is more complex than I will probably give you, but not too terribly difficult. At least follow it along. Now I'm going to then talk today about section, let's see, 8.5. So let's go ahead now for the new concepts. Okay, so looking at this new concept, we're talking about reducing radicals to the same order. When you think same order, think same index. We can only add or subtract radicals when they have the same index and the same radicand. Radicand is the number under the index. So, for instance, here, if we have, let me get another color here, if we have the square root of 5 plus 3 times the square root of 5, we can add these, and we'll be doing that in the next section. And so that would give me 4 of those things, 4 square roots of 5. But if I had the square root of 5 plus 3, the square root of 2, even though they're both square roots, this has a different radicand, and so that cannot be simplified. Now, before we then go into the next section where we'll be adding or subtracting, we do need to learn how to convert different terms to a common index. So what you do, let's say we have these 3 terms, the cubed root of 2, the square root of 3, and the fourth root of 5. We want to convert I'm sorry, let's not say this part here. That's going to be later. I thought we were going to do more. Okay, so let's just look at this. Ignore that idea. We're going to convert a cubed root, a square root, and a fourth root to a common index. I don't mean root. A common index, and that common index would be the same as finding the least common multiple. Between 3, 2, and 4, what's the first number common that could be divided by all three of them, and that would be 12. Okay, so how are we going to convert each one? Well, let's look at the first one, the cubed root of 2. To go from a cubed root to a fourth root, I need to multiply by 4. So I'll multiply to get the index of 12. 3 times 4 is 12, and therefore I'll need to take the radicand and raise it to the fourth power. So that's the same as the 12th root of 16. Okay. The next one, I have a square root. To multiply to get 12, I'll need to multiply it by 6, so I'll raise the radicand to the 6th power. And finally, the last one, I've got a 4 as my index. I want it to go to 12, so I need to multiply it by 3, so I need to raise what is under the radicand to the 3rd power. So study those examples. That should be fairly easy. And now, let's do another example. I have a 2 and a 4. My least common, or my new index, would just be the 4, so I don't need to modify the second one, but I do need to modify the first one. I'm going from a 2 to a 4, so I need to multiply by 2, meaning raise the radicand to the 2nd power. And so this one would be converted to that. And finally, one more example. This is a 2 and this is a 3. My new index has to be a 6. To convert the first one, to convert from 3 as an index to 6 as an index, I want to multiply by 2, and so now I will raise what's the radicand to the 2nd power. So that would be that. For the next one, I want my new index to be 6. I need to multiply by 3, so I'll raise my radicand to the 3rd power, and simplifying or multiplying it out, I will get this. So that should be good enough to get you started on the homework here. For your homework, I want you to do 8.5, 1 through 25 all. Let me go to the next page for just a second. So we're doing 8.5, 1 through 25 all. I do want you to keep up on your homework, so try to have this finished by Wednesday, even though we're not meeting. It will be a very good idea for you to keep up, because between now and Wednesday, I want you to tell me anything that's puzzling to you so I can address that in the next tape, which will be tape lesson 27B, which I will be taping on Wednesday and posting. So we will keep in order. It might be at certain times I will go ahead and email you all, or send you in some way quizzes, and depending on how long our non-meeting time will be, I might even send you a test or two. So it's very important that you keep abreast in a timely fashion. Now, if you have any questions, I want you to text me at 505-301 and 1357. I want you to text me the problems that you're struggling with, especially from the ones we've already corrected. I probably posted this before. I'm trying to remember. So problems that I sent the answers to, or concepts in the new work, or past work. And again, I won't be addressing you individually, but I will make sure that I address those things on the next test, or on the next tape. So have a blessed, wonderful day, and really, I would exhort you to be thoughtful about how you use this season, how God would have you to use this really quite extensive break, a large portion of time So be thoughtful in how He would like you to engage that time. And blessings to all of you.